Today we are going to superheat steam. We have a copper coil, solid copper tubing that is in a dual hole stopper, and in there we have an Erlenmeyer flask. In the Erlenmeyer we have ice water sitting right at 0 degrees. That copper tubing comes out. There is a burner underneath that copper tubing, and the entire Erlenmeyer sits on top of a hot plate. We are going to turn the hot plate on. Obviously that hot plate's going to get hot. It's going to heat up the contents inside the Erlenmeyer, presumably going to melt the ice. As that ice starts to melt, we'll start seeing some phase changes. After that, we'll see some temperature changes, and then we'll see if we can superheat that steam. As the ice is melting, the temperature stays right around 0. Once it's done melting, we start to see an increase in water temperature. Now, we check the hot plate temperature. Made a mistake. I'm measuring in Fahrenheit. My apologies. But I see a huge temperature jump in the hot plate. It's almost 1,000 degrees. And it's only 30 degrees Celsius on that thermometer. Once the water in the Erlenmeyer begins to boil, we reach temperature right at 100 degrees. That steam is going to be coming out the end of that tube. You can see it kind of shooting out there. We want to verify some temperatures. So again, we'll take the temperature of the hot plate. Me mistakenly, again, firing up in Fahrenheit. Sorry about that. I'll switch it over in a second here. So we're looking at about 900 plus in Fahrenheit. And as I remember that we are in science class and we only use Celsius. Here we go. We're looking at it's going to be 500, and that thermometer actually maxes out at 500 degrees Celsius. We want to check the temperature of that steam coming out of the end, and as we do, okay, we can basically see that it's under 100 degrees. So we have a hot plate at 500 degrees, boiling water 100 degrees. That steam, after it's cooling down coming out of that end, is dropping below 100 degrees. So those are just some things that we want to keep an eye on and take into account when our goal is going to be to heat that steam to actually a point of lighting paper on fire. Again, just checking my temperature of my hot plate again, and it fluctuates. It's hard to get a reading on it, but it's sitting right at that like 500 mark. Now for some fun. Let's burn paper with water. Keep in mind, the only thing coming out of that tubing is steam. First off, I do not have that burner on. All it does is basically makes the paper wet. That's not very fun. Let's light that burner up. Couple reminders. Hot plate, 500 degrees. Boiling water, 100 degrees. Initially, that steam was coming out under 100 degrees. Now that we have the burner going, we see that it's at least over 100 degrees. Now, how hot is it? That's the goal. What we want to do, again, is burn paper with water. Let's do it. Just remember, the only thing coming out the end of that tube is steam. Water. There is no fire. That is solid copper tubing, and now you can see I am definitely burning paper with water because we are superheating that steam, increasing its kinetic energy, increasing its temperature to the point that I can burn that paper.